Today we are going to solve trig equations using double angle identities. So our first example here is the sine of 2x minus the cosine of x equals 0. So if you remember on the back of your identity sheet there, you have a nice double angle identity that says sine of 2x is equal to 2 sine x times the cosine x. We are going to use a substitution, and we're going to take that and we are going to substitute it in over here for 2x for this whole entire thing. Alright, so let's do that. Let's take 2 sine x cosine x and we still have minus cosine x equals 0. Now notice at the 2 sine of x and you got a cosine x. Those are two different terms. So if you notice the first term and the second term there, what do they have in common? Oh yeah, they have cosine x. So let's pull the cosine x out because that's its GCF. So the first term have left 2 sine x. And there's a minus sign between them. And then this term over here has a 1 left. So now you can take cosine x and set it equals 0, just like we do regular factors. Take each factor, set it equals 0, solve for the trig equation, then solve for x. So where is the cosine of x equal to 0 on the unit circle? Oh yeah, cosine is 0 at two spots. It's there at pi over 2 and 3 pi over 2. Now over here I can solve this. I can add 1 and divide by 2. So I can solve for sine x. And where is the sine of x there equal to 1/2 on the unit circle? Two places. You got one in the quadrant 1 and you got one in quadrant 2 where sine there is positive. And so those two spots are pi over 6 and 5 pi over 6. Alright, so now we are going to look at another similar problem. And again, you gotta kind of look at your identity sheet and start knowing some of those values. So this one here is the cosine of 2x is equal to cosine x. So they don't have the same angle in this case. One has the cosine of 2x, the other one has the cosine of x. You need to put them in terms of the same angle. So in order for us to do that, we are going to have to go ahead now and rewrite the cosine of 2x. So on your identity sheet, we want to pick the one that's going to help us the most. Since we've already got cosine x in the problem, you don't want to choose any of the ones that involve sine. So there's only one that does not involve sine and just involves cosine. It is the cosine of 2x is equal to the cosine squared of x minus 1. So we're going to replace the cosine of 2x there with 2 cosine squared x minus 1. Alright, so now since we got a quadratic, let's bring everything over on one side. So now, on the left-hand side, I'm simply left with 2 cosine squared x minus cosine x minus 1 equals 0. Factor the left-hand side, because now you've got a quadratic. What times what gives us 2 cosine squared x? Be 2 cosine x times cosine x. What times what gives us a minus 1? It'd be a negative 1 and a positive 1. Decide where they have to go. So I have to put the minus 1 here, and the plus 1 has to go here in order for us to get a minus cosine x in the middle. So now I can say 2 cosine x plus 1 equals 0. So I'm taking each of those factors now and setting those equal to 0. So on the left-hand side, I can subtract 1 and divide by 2. And over here on the right-hand side, I can just add 1. So now I know over here, I have to think about where is my cosine there, negative 1/2. So cosine is negative over in 2 quadrants. It's in quadrants 2 and in quadrant 3. So the cosine is negative there at 2 pi over 3. And then at 4 pi over 3 down there in quadrant 3. Alright, and then where is my cosine there equal to 1? My cosine is equal to 1 only in one place, and that's at 0. We don't include 2 pi on that, so it's just 0, 2 pi over 3, and 4 pi over 3. So let's try another one of these. So now this one is a little bit different. This one here has negative 4 cosine squared x minus 8 sine x plus 7 equals 0. So we have a quadratic, but they don't have the same, they're not in terms of the same trig function there. One's got cosine squared, the other one has sine. So they both have the same angle, they're both x's, so we're not going to do anything with double angle or half angles. We have to replace that cosine squared, because this is like the ones that we did last time here, where we could just replace that cosine squared there with 1 minus sine squared. So let's do that. Let's replace, so, and come over here and write it out. So cosine squared x is equal to 1 minus sine squared x. That way we'll have the entire problem here in terms of sine. So I want to erase this. Alright. So now we have 1 minus sine squared. I'm putting that in for the cosine squared. There's a negative 4 out here in the front. And then I still have a minus 8 sine x. And then plus 7. So now I'm going to go ahead and use my distributive property and distribute this negative 4 through. So I get negative 4 plus 4 sine squared x minus 8 sine x plus 7 equals 0. I'm going to put them in the right order. So 4 sine squared x minus 8 sine x. I'm going to combine my like terms, so that negative 4 and that plus 7 there is going to give me a plus 3. Alright, so now I see I've got a quadratic. I've got 3 terms. I'm going to go ahead and factor this. So 4 sine squared x there, I'm going to say, oh yeah, 2 sine x times 2 sine x will give me 4 sine squared x. What multiplies to give me a positive 3 but adds to give me a negative? Oh yeah, one's got to be a minus 3 and one's got to be a minus 1. So if I check my inners and outers here, I've got a minus 6 sine x and a minus 2 sine x, which adds to give me a minus 8 sine x. So I'm going to go ahead and finish solving this one. Two sine x minus 3 equals 0. And 2 sine x minus 1 equals 0. So solving the left one here, we get sine x I can add 3 and divide by 2. I get the sine of x equals 3 halves. Over here I can add 1 and divide by 2. I get the sine of x equals 1 half. Right, kind of running out of space over here, but that first one there where sine of x there equals 3 halves, there's no place where your x value there is going to end up giving you 3 halves there. You can't get a sine of 3 halves there, so there is no place for this one here. So there's a no solution for this one. This one here, you have to think about where your sine there is going to give you 1 half. It's in quadrant 1 and in quadrant 2 there. So in quadrant 1 there, what's that going to be? Pi over 6. And in quadrant 2, 5 pi over 6. So 2 places. So sometimes we have to get a common denominator in order for us to solve these. So let's do that. So one we're going to use this time is, you see you got 2 different trig functions. You've got secant and you've got cosine. But we can rewrite secant in terms of cosine. So we can use that trig identity there, one of our definition of trig functions. Secant there is equal to 1 over cosine. So I'm going to replace that secant there with 1 over cosine. The reason why I chose to do that is there wasn't a GCF of like secant x in this whole thing, or a GCF of cosine. So there wasn't really anything for me to do except change them all in terms of cosine. So I'm going to bring everything over here on the left hand side as well and set equals 0. I'm going to multiply over here, so I get 3 over the cosine of x minus the cosine of x minus 2 equals 0. It's too hard to work with cosine when it's down here in the denominator down there. So I'm going to go ahead now and multiply every single term in here by cosine x to get this cosine x off the bottom. So multiplying every single term there by cosine x. The first term there, now this one over here, the cosine x there will cancel out, and I'm left with 3. Cosine x times cosine x there is cosine squared x. Minus 2 cosine x equals 0. So now I'm just going to put them in the right order. Negative cosine squared x minus 2 cosine x plus 3 equals 0. So I'm going to take a negative out of this whole thing because I think it's too difficult to factor when you've got a negative here in the front. So I'm going to just change the sign of everything in here. So this becomes cosine squared x plus 2 cosine x minus 3. Alright, so let's continue factoring that. I still have a negative 1 out here in the front. Now looks like I got a squared term, a middle term, and a last term there, so I might as well factor that. So what times what gives me cosine squared? That'd be cosine x. What multiplies to give me negative 3 and adds to give me a positive 2. That would be a positive 3 and a minus 1. So since outside here, this negative 1 here on the outside can just, it's not going to impact what the values actually are. So I can say cosine x plus 3 equals 0. And I can say the cosine of x minus 1 equals 0. Alright, so I can solve here for cosine. I can subtract 3. Over in the other one here, I can just add 1. So where is your cosine there equal to negative 3? Nowhere. Where is your cosine equal to 1? Cosine's equal to 1 in one spot, and that is at 0. So my solution there is simply x equals 0. Alright, so similarly is this one here. This one here, we've got cosecant and we got sine. Notice there's not a GCF in that problem, so my only real thing that I can do right now is to go ahead and change that cosecant into sine so that we end up having the same trig function. So cosecant is 1 over sine. I'm going to go ahead and bring my 1 over as well. I can multiply here and I get 2 over sine x. Alright, so I can't really work with sine when it's down there in the denominator down there, so I'm going to multiply, just like we did in the last problem there, we're going to multiply all of the terms here by sine x. So what happens over here is that the sine x's here can cancel out, This is exactly what we wanted to have happen. So I get 2 minus, and here sine x times sine x is sine squared x, and then minus sine x equals 0. So now I'm just going to rearrange them. Negative sine squared x minus sine x plus 2 equals 0. So again, I've got a negative here in the front. I could either bring them all to the other side to get rid of the negative as well. It wouldn't really matter. But I'm just going to pull this out here. So sine squared x plus, so I'm changing the signs of everything here to the right. Running out of room down there, so let's come up here. So I still took the negative out. Let's factor this thing now. What multiplies to give us sine squared x would be sine x times sine x. And then what multiplies to give me negative 2 and adds to give me a 1, that'd be a plus 2 and a minus 1. So again, I don't have to worry about that negative on the outside because it's not, it doesn't have an x in it, basically. So it's always going to be negative 1, it can't be anything else. So then the sine of x minus 1 equals 0. So over here, the sine of x here is negative 2, so solving for sine x in every single case, adding 1 over here, we just get sine of x equals 1. The sine of x over here is never going to be negative 2, so that's a no solution. Over here, where is your sine of x? They're equal to 1. That is in one spot, and that's at pi over 2. So we can solve trig equations using double angle identities. And so you're going to be working on that worksheet.